As a quick startup for this section of the lecture, I wanted to start with this. Anyway, when part of the brain is damaged, usually due to disease or an accident, scientists have an unexpected opportunity, as I said before, to gain more knowledge of which parts of the brain do what. All right, in 1848, there was a particularly bizarre incident, an accident in which a 4-foot-long pole was driven through one side of a man's skull and out the other. Okay, doctors managed to remove the pole, but Phineas Gage, the man, was a changed man, okay? Personality and everything. Various aspects of his personality were altered, apparently not for the better, according to his wife, and he had difficulty controlling his emotions. However, Mr. Gage lived another 13 years. So here is the drawing of his skull. I can't make it bigger, and the resolution isn't very good, but they didn't really do any repair except pull out the pole, and for the rest of his life, Gage carried the pole around with him. Here's a picture, an actual picture of him with the pole, and you can see perhaps there that it wrecked his eye. I don't know whether he lost the vision in it or just the eyelid or whatever. But anyway, that's all about that. Another possible result of brain damage due to accident, disease, or stroke is the language deficit called aphasia. Okay? Since the earliest times, there have been descriptions of people with various types of language impairment following some sort of damage to the head. The study of aphasia has become an important area of research for neurologists. Depending on which part of the brain the damage is in and what the impairment is, they can better define the function of a particular area. In general, although people with aphasia exhibit various types of language impairment, their basic intelligence and cognitive functions remain unaffected. The ability to process language is process it normally is affected. There are several types of aphasia involving various areas, aspects of language memory loss. The most severe is global aphasia, where the person is completely mute, but most types of aphasia are characterized by a loss of only a particular aspect of language. Broca's aphasia, or agrammatic aphasia, is a type of non-fluent aphasia caused by damage to the lower part of the left frontal lobe, you know, the Broca's area that we spoke about. This results in halting speech and an inability to string words together, problems with syntax. If you look at the examples from a Broca's aphasic in your text, you'll see the lack of function words such as articles, prepositions, and even verbs. You can, if you go to YouTube, you can see some of these. There are some files there for Broca's aphasia and Wernicke's aphasia, and I urge you, if you're interested, take a look there. The inability to process such function words is very frustrating for the agrammatic aphasic. As you might expect, a person with Broca's aphasia has just as much trouble decoding the syntax of the language spoken to him as he does with forming his own utterances. Wernicke's aphasia, on the other hand, is a type of affluent or of fluent aphasia caused by damage to Wernicke's area, which is back here at the top of the temporal lobe, back of the temporal lobe too. Results in fluid but nonsensical utterances. Again, you can find this on YouTube if you're interested. A person with jargon aphasia, okay, which is a type of Wernicke's aphasia. This person speaks fluently but has trouble choosing the right sound to say. Consequently, he often picks the wrong sound, says the wrong word, or makes up his own words. These YouTube things are good for that. A type of aphasia associated with reading is called acquired dyslexia. Unlike the letter reversal kind of dyslexia, which is developmental, something that many of you teachers are familiar with. Acquired dyslexia tends to substitute phonologically or semantically related similar words to the words that they're trying to find. ones that sound alike or have similar meaning, right? And so I think you can find that too. A rather strange type of aphasia is called bilingual asymmetry. It's a bilingual person's total loss of the ability to speak one of the languages that he totally had command of before the brain incident. One last type of language loss is is that which we all have a taste of from time to time, the feeling that a word that you want is right there on the tip of your tongue. They even have an acronym for it, TOT, tip of tongue, okay? But you can't get the word out, right? An aphasic who can never succeed in finding the word suffers what's called anomia or anomia, okay? But, you know, this only happens to us now and then, so I don't think we're aphasic. Okay, the fact that there are different types of aphasia involving impairment of particular aspects of language as related to particular areas of the brain. This is further evidence that language requires different discrete processing modules, and that these modules are processed in specific pinpointable areas of the brain. For example, the observable differences between Broca's aphasia and Wernicke's aphasia demonstrate the fact that the processing of content words and the processing of function words takes place in different parts of the brain. Even more puzzling divisions of cognitive functions have been observed, such as the loss of the ability to name only one type of thing, such as colors or animals or tools or something. Yeah, it's fascinating.